Hello everyone, this is the second lecture of trigonometry, and today we will discuss about angles and measurement of angles and all these stuffs. We have studied in the last lecture about what is angle and and important properties of triangles like congruence and similarity. And we have seen some application of similarity. Now we are discussing one of the most important and core thing about trigonometry, that's the measurement of angle. So we have studied about what is right angles. So it's simply now we have to measure that what right angles, and how can we measure using any instrument haven't defined yet. So now first thing is we are moving here to in measurement of angle. We have the first way of measuring angle is sexagesimal. Similar way of measuring angle. And this is quite simple, that it is defined as like that: each right angle each right angle is divided into two 90 equals part 90 equal parts, and each part is called a degree. It's simply that we have right angles, and then we divide each right angle into 60 parts, just like that. And we have theta 1, theta 2, that's I don't know, and each are of the same unit, and we have 60 equal parts, and each are of same unit, and the first the first thing of measuring angles. So another question is that, what about, and why we divide a right angle into 90 equal parts? There is some historical background too, why we divide a right angle in 90 equal parts. Because it's more about, when we take a one revolution, it contains four right angles. Yeah, one revolution contains four right angles. So in our years there are 365 days, 365 or 366 days, and we take 360 degree as one revolution. when when one a when we have a ray when one ray revolves around another and it complete one full turn, it makes 360 degree. And why we take that is because 360 has important property likes that it is divisible by 1, 2, 3, 4, 5, 6, not 7, 8, 8, 9, 10, not 11. Yeah, that's when we, and this one, and when we to then we have something that we won't be able, we won't be in such situation that we must, we may feel that the we have to deal with fractions, and it is quite simple when we have whole numbers as an angle. That's why maybe that's the reason of taking 360-degree as one revolution, and we take, and that's how we define sexagesimal way of measuring angles. And another second thing is that there is another second thing that is grade, and in this we define each right angle. Each right angle is divided into 100 equals part. So here we define each right angle in 100 equal parts. Yeah, that's great. We define that one right angle is equals to 100 grade each, and here we define one right angle is equal to 90 degree, and that's called degree. Nothing simple, and that's how we define measurement of angles. We have seen sexagesimal and grade. There's another third way of defining. There is also third way of defining the measurement of angles. Now it's about angle. It's about that's called circular rate and circular measurement. Circular measurement. So let's suppose I have a circle and I'm just taking any concentric circles. So these two are, and that's our, and we are defining that angle. So this is R1, and that is R2. See, this length is L1, this length is L2, this length is L1. And now we take, and theta is approximately so close. We take theta approaches to 0, maybe 0, maybe 0. Yeah, theta approaches to 0, not 0, so 0. So we see that L1 by L2, we see that these two triangles are similar, so we can conclude that L1 by L2 is equals to R1 by R2. And we have just defined, or it can be also written as L1 by R1 is equal to L2 by R2, and we can say that is theta, and we can simply define is like that, and now we get L is equal to R theta. So that's the circular view measurement, and we define theta is equals to L by R. That's the one part of the measurement of angles. Now let's study more about circular measurement. Circular measurement. And we need to know that how to obtain the circle. It's not an easy to get exact circle, but we need something called exhaustion. And that's the main thing we need to know. That let's suppose I have a polygon. Yeah, I have a polygon, and that let's suppose I have a polygon. I have a polygon. That's the polygon. Polygon of n sides. N sides. And we are about, and that's regular. That's regular polygon. So what does it mean by regular? It simply means that we have polygons that has equal, each angles are equals, and their sides, and all the sides are equal. That means the regular polygon of n side. And when we have a regular polygon of n side and we limit n, yeah, that's limit means simply we are trying to approach that n to the infinity of that polygon, to any polygon. And that's not rigorous way of writing this, but we can understand that we get a circle. That's what does it mean. How to get circle from polygon? We increase the number of sides of regular polygons, and we will get the polygon. We get the circle. So we use that thing again. Now I have a concentric circles. Concentric circle means they have same centers. So now this is circle. Now we are writing this is OA, B, C, D, and now we join this. Simply we can know that, and we have seen that OA by OB is equals to OA by OB is equals to AC by BD. AC by BD, or that is simply, now we know that OA we call that is R1, this is R2, so R1 by R2 equals to AC by BD. Now we can increase its sides by multiplying by n, and that's this is some part of the polygon. BD is the side of some polygons, so we are increasing that sides simply, and that's the ratio would be same. So when we increase the sides and approaching that limit, so when we taking a limit on both sides, r1 by r2 is equal to limit, and that's n approaches to infinity, and n approaches to infinity, n a c by n b d, and that's and that's simply and that's one is that's simply the circumference. Now let's see, this is c1 and this is c2, and this is simply that is circumference of c2 c1 by circumference of c2, and that's, we are not defining limits rigorously, we are using just as intuition, so it is correct. Yeah, we have just used the calculus notions of limit. So that's the circumference of c1 and that's the circumference of c2. So now we are getting that r1 by r2 is equals to circumference of c1 by circumference of c2. Now we can see that, we can rearrange that. Now we get circumference of c1 by r1 is equals to circumference of c2 by r2. Now we can see that this is always true. This is always true when we can see that constant. We can say that constant is pi. So we have proved that we have any circle and their circumference by their radius is always comes to that ratio. That ratio we haven't find that yet, and we don't need to find it. As the coolest part is that now we use this for measuring angles. So now we have find the ratio between circumference and radius. Now let's move to the next thing, that is okay, sorry, I did a mistake here. Like that, we have get that circumference by c1, and there is another 2r1, that's simply the diameter, and 2r2, that's how it's defined pi. So now we have defined pi is equals to circumference by diameter. That's the definition of pi. So we have defined theta as equals to L by R, so that L is arc length, R is radius. So now we use that definition of pi to get some relation in radian. So now pi, now we from here we can say that circumference, from here we can say that circumference is equals to 2 pi r. Okay, so now a circle, I have a circle that's the circumference is 2 pi r. So what will the angles it covers? So the angle is 2 pi r by r, and that says 2 pi. So a complete circle makes 2 pi radian. Yeah, one complete circle makes angles 2 pi radians. And then half circle, semicircle makes angle pi radian, or we can say that 2 right angle makes pi radian. And now that's the last definition of, that's the last definition of circular measurement. Now we are seeing some interchanges between sexagesimal, grade and radian. Now first, so we have two right angle is equals to 180 degree is equals to, and we not equals to, we equivalent, we call it equivalent to 200 grade is equivalent to pi radian. So now it's simple, so we can write as we just need unity method to convert and calculate whatever we want. So that's the interchange, and we don't have nothing, that's the elementary method to change radian into the grade into degree. These are all the child stuffs. Now another part to move on, that is a right angle. We need to understand right angle triangle in order to understand the trigonometry from it. Because all our ratios are defined on that basis. So now move to the another thing about that is right angle. Right angle. So right angled triangle. Yeah. So it's simply that one angle one angle is right angle. That's the right angle. And this is, let's call this is theta. So now we are defining something that's the longest side. Opposite Opposite of right angle is called hypotenuse. And opposite of what we have theta. So how when we define something, because it is important, opposite of this angle we call that opposite, simple terms, or we can say that perpendicular, and this is adjacent side to this, so we can call at base or adjacent. You can see those things simply. Okay, now this is simple thing you need to know. Now there is another thing that is called Pythagoras theorem. We will prove this. It's quite simple. I have a triangle. Now just this is right angle. Now just drop a perpendicular. Now just drop perpendicular from B to AC on hypotenuse D, and look that triangle ABD is similar to triangle ABD is similar to triangle ACD and ACB, that's ACB, and that is similar to triangle CBD. Now we can write as AB by BC now not AB by BC, let's take AB by AC is equals to AB by AC is equal to, let's take AD by AB, AD by AB. Now this implies AB square is equal to AC into AD. Similarly, ABC square is equals to CD into DA, CD into CA, and from first and second, on adding both of them, we get that AB square plus BC square is equals to AC plus AD plus CD, and that is AC square. Now we get a result. The most important thing, that is I have a triangle, let's call it A, it's called C, let's see, that says A and that is B. So A square plus C square is equals to B square, and that says Pythagoras theorem. theorem. And that's all we need to understand of about right angle triangle. Now look to the trigonometric ratios. Metric ratios. Now see, that's the triangle. That is right angle triangle, and that is opposite. That's base or adjacent side, and that's its hypotenuse. Now we define sine of theta is as ratio opposite over hypotenuse, and cos theta and cos of the theta as adjacent by hypotenuse, and we define tan theta as opposite over hypotenuse. Now we take the reciprocal of both these. 1 by sine theta is equals to cosec theta. Cosec theta, that is hypotenuse by opposite, and we guess cos theta, 1 by cos theta is sec theta, and that's simply an cot theta is defined as hypotenuse. Oh sorry, that's not hypotenuse, that is adjacent. So adjacent over opposite. So that's the trigonometric ratio, and we have just seen. Now look some important Pythagorean identities. Identities. That is, we don't say Python identities is not ideal for now. Say that some corollaries of Pythagoras. So we have defined now just look at this: A, B, C. This is C, this is A, this is B. So now we can write C as, from here we can write C as, now this is theta, then C as B sine theta, and A as B cos theta. And we can then write C square plus A square is equals to B square sine square theta plus B square cos square theta, and that is C square plus B square is equals to B square plus sine square theta plus cos square theta, and that gives to that implies sine square theta plus cos square theta is equals to 1. That's the identity, and that's the first corollary of Pythagoras theorem on trigonometry. And second is now we can just divide by sine theta. sine square theta, that is 1 plus cot square theta is equal to cosec square theta, and similarly we can divide this sine square theta plus cos square theta by cos square theta, and we get tan square theta plus 1 is equal to sec square theta, and that's all. So this ends our lecture. We have studied so far angle measurement and the Pythagorean theorem and the trigonometric ratios, and these are the some important corollaries about trigonometric ratios that we need to learn or memorize, whatever you want to do. Thank you for second lectures, and I will upload next lecture on the next week. Okay, have a good day.